Thank you. Hey, uh, I know some of you, some I don't. And I'm really glad that you're able to kind of hang out with me for a little while. It's been a crazy kind of 2 weeks, but it's been a crazy kind of year. So wherever you are and whatever you're up to, whoever you're with or not with, it doesn't matter. Hope everybody's feeling good, safe, and happy. Thanks a lot for giving me a few minutes. You can see there on the board, my name is Jay Gordon. I work in Microsoft. I'm a cloud advocate. That means I like to talk to people about Azure. It's really cool. It's a great job. Nathan does something kind of close to what I do. And that means that we basically get to play around with these like incredible clouds for a living and then tell people what we learn. It's a pretty awesome job. If you want to follow me on Twitter, it's at jdestro. You can also follow me on GitHub. I've got a bunch of projects that you can follow that will help you do stuff with Azure. Um, I got a shill for a second. Sorry. If you don't already have an Azure account, you want $200 free and 12 months of free Azure. Please use this. It's for me to tell the people I work for I do a great job because you used it. So thank you very much. I appreciate it. Once again, I got a lot of cool projects going on. I want you to check out some of them. One of the big things I'm doing is Azure Fun Bites. It's a weekly Twitch story. The other thing I do is I work with DevOps Days New York City. Adarsh and I are a big part of making sure that this city in New York, as well as reaching out to people out in New Jersey, that we have a DevOps Days in our region that's sustaining and great. So some of you were there. I really appreciate that as well. So today we're going to talk about ARM and ARM templates as to kind of get into it. Terraform and Azure. I'm sure a lot of you know what HashiCorp Terraform is and how you can build infrastructure using it. And then we can chat about your options if you got some questions after John Best here gives us a little bit of a demo about Kubernetes and deploying it using Terraform on Azure. So as always, one of the cool things that we always say at Microsoft is this is the way we look at DevOps. It's the union of people, process, and products to enable continuous delivery of value to your end users. I feel like that's a really great kind of base statement about all the things with these kind of meetups and DevOps days. It's not just about pipelines. It's about bringing people together, and that union creates that continuous delivery, that continuous integration, that conversation, and the things that we do beyond just committing to GitHub. Those are important. So when we think about that, it's a really great way of thinking about all these things we do to develop, but that we also talk about it. We talk about how to prevent the real bad things from happening again too. So with that in mind, we want to talk for a second about infrastructure as code. This is one of the real table stakes, I think, of DevOps. We look at infrastructure as code because when the DevOps movement kind of came into fruition, one of the real drivers, enablers, were these tools that codified your infrastructure, and it made managing, provisioning, and configuring application environments look what they were supposed to look like. So you didn't have a bunch of stuff kind of with configuration drift. You didn't have tons of servers that were running old versions, new versions of things, different config. We finally found a way to get things to work. And now when you look at a lot of infrastructure as code and configuration management, we've reached a point now where we're looking for agnostic tools. Agnostic tools really become important because while I work for Microsoft Azure, I am pretty realistic that there are targets that you may be interested because maybe your project may not allow for Azure. Either way, it's great to be able to use these basic tools or complex tools, whether it's something as basic as Cloud Init or something really, really complex like Kubernetes. Ways to just codify what we're doing and make it simpler so that you can have things on any environment, any cloud, or any data center. So why infrastructure as code? I mean, it's pretty simple. We help increase speed. We really reduce risk. we reduce cost, of course, and then we just leverage developer best practices. So the things that our group in the software development team, maybe they're writing JavaScript, we're trying to mimic the software development practices that they're doing in the way we actually write our infrastructure as code. So a testing process, running things through suites of tests to make sure that when we build our infrastructure, it actually builds the way we make those assumptions. So that helps us be able to remove the human element and build things quicker. We can have that visibility into our environment so that we can reduce our costs. And of course, you keep everything in a repo. And isn't that really what this is all about? It's just taking what your infrastructure is, putting it into some code and throwing in a repo so that you can build what you need anytime. So there is native to Azure, Azure Resource Manager. And what we can use is declarative code to grab, we can manipulate, we can destroy all these different resources for Azure, and we can do it in a codified and native way. So it's really a deployment management service for Azure, Azure Resource Manager. It provides you with a management layer that allows you to create, update, delete, and you can use management features to access control, locks, tags. You can do all these things to make sure that your cloud looks the way you expect your cloud to look every single time. And so one of the things that has really benefited people that have moved them into doing their infrastructure as code within Azure is using Azure Resource Manager templates because we're going to be using templates, not scripts. So we're not going to be writing something in Ruby. We're not going to be using another DSL. We're just going to be doing everything within JSON. And that's going to lead into kind of what I'm going to talk about next. ARM templates, what are they? They're declarative code. JSON is how everything is, and it allows you to use a declarative syntax, which lets you state what you intend to deploy without having to write the sequence of programming commands to create it. In the template, you can specify the resources to deploy and the properties for those resources. So you have a declarative syntax, repeatable results. You can create any Azure resource required. It's got a testing suite built into it. You can use a built-in validation. And the other great part of it is all of it is exportable. So you can go right into a template and export what you want. So you're literally getting what you want and how you want it every single time. I'm going to bring up really quick. I've got just a Git repository that I wanted to show you. Let me find it. You know what? Don't worry about it. I'd rather just stick to the presentation so we can get John to show it. I thought I had that URL up. Maybe later on I'll send it so we could take a look at it. But I wanted to show you what an ARM template, how it looks. But essentially, this is a really great example of how an ARM template could be used as a 3-tier with multiple resources that we want to build in one piece of code that's just all in JSON. And so how you define templates, Azure Resource Manager essentially converts the template into a REST API operation. For example, when ARM receives the template with the resource definition like this, so this is for creating some storage, we get a response right here of what we got, and you can see as it converted the definition to this REST API operation, was just eventually just sent to the Microsoft storage resource provider. So we're using all these native tools within Azure to build things repeatably, quickly. And so the one thing that you can use to really leverage the speed of using these templates are a bunch of quick starts that Microsoft Azure has ready for you to use. So you can do things as simple as a Ubuntu VM or something really, really complex like the Azure VM with a new AD forest. So these are things that you basically just put information into with parameters. And those parameters eventually allow you to build all these different types of resources. So this is the repo I wanted to show you before. And I wanted to show you that Azure deploy.json file. I just didn't keep the link. I apologize. I'll get it and show you after John does his thing. But anyway, as you can see, everything is just code in a repo, and it's just JSON. There's nothing crazy here. You basically can leverage a couple different ways to then use that JSON. So either you can just use the portal. So you'll go into the portal, you'll ask to load a template. The template will eventually give you a place to either put in different parameters or use the pre-filled parameters. And then you just click purchase and it just builds it. The other options are both via PowerShell, where you can just run a short PowerShell script and provide the Azure deploy.json, which is eventually the template that you're going to run. And then there's Azure CLI, which runs on almost any platform or in the Azure Cloud Shell. And then you can just run this and same thing, provide the location of the template file and then build it. So these are just two different ways of deploying some storage and another one to deploy a resource group. And then within that resource group, you're in the PowerShell one, you'll see that eventually it will deploy all the requested resources in that Azure deploy.json. Cool? All right, I'm going to keep moving fast because I'm almost done because I want John to do his thing. So if you're new to ARM templates, if you find it interesting, go to this link. There's a bunch of free tutorials and education that you can use, teach you really quickly how to get started. So the next thing I want to talk about is a more independent and non-Azure specific tool. So this is an agnostic to cloud tool. And I think a lot of you may have heard of it. HashiCorp is one of the bigger cloud creation management tool providers in the world, even down to being able to help you run a VM on your computer with Vagrant. It's pretty damn great. So what Terraform is essentially a way of doing a lot of the things that ARM does. ARM is just a native version. Terraform is a cloud agnostic version. You can run it on pretty much anything. It doesn't matter. And so it's the same concept of declarative config files. You plan, so you put everything into plans. Those plans are run. And then essentially when you run those plans, it's repeatable, reproducible infrastructure. And I believe everything is idempotent so that if you run it and you run it again, it won't duplicate your infrastructure. It will do exactly what you want every single time, the way you want it done. And so one of the ways of implementing Terraform is being able to use Azure pipelines. These are cloud-hosted pipelines that you can use any platform, anything you want to use. And this is another one of the great things that we can do here is we could use Terraform to build our Kubernetes and all the things we need for it. And then eventually we can use Azure pipelines to manage the deploy process and the build process. So here's an example of using Helm and installing an ACR, I should say adding a Helm ACR and then a Helm upgrade. And then here is an example of one of the plans to build what it is we need for the kube admin to integrate our eventually our build from Azure pipelines into a Kubernetes cluster. So we get all through Azure DevOps, a singular pipeline resource for both builds, testing, and on top of that, our release. So you can release to almost anything. You can see, I know it's called Azure DevOps, but you can see right there on the side, Amazon ECR, Amazon S3. This is a platform for anything, anyone. Nathan could go and build something with Google and then eventually deploy using Azure DevOps. It doesn't matter. And so one of the things John is going to talk about next is the fact that Microsoft Azure really loves Terraform. Azure is great as a deployment target. You can use the pre-installed binary on the Linux build agents. Azure DevOps can be used as a VCS provider for Terraform. And there's actually a native Azure Cloud Shell support. So you can go into the Cloud Shell and use Terraform, right? So you don't even need to do anything but clone where your plan files are, run it, and do it right from the shell. So if you have any questions for me after, I will take them, but I want John to go ahead and take over from here. Okay, let me stop my share.
Thank you, Jay. That was great. I love that you mentioned Cloud Shell, because that's exactly what I'm going to use, because it's easy, and I already have an entire setup, an entire setup ready to go. So yeah, so as Jay was saying, Azure really does have great support for Kubernetes, and in my experience, it's really been fantastic how easy it is to get up and running with Kubernetes on Azure. And actually, when I was doing some testing, I actually found out it was a lot. In my experience, it was a lot faster than some other offerings, which I was very surprised by. I was not expecting that, so I thought that was very cool. And here at XOps, we definitely are all about using things like Terraform as a force multiplier to help organizations deliver better software faster. And we take great pride in leveraging infrastructure as code to to help organizations be more agile and help organizations do better at their software release process, and that's definitely what we've been passionate about for a good while. So I guess since Jay covered everything mostly technical about Kubernetes and Azure, I guess I'll just jump right into the demo, if that's all right. All right. Let me know when you all can see my screen.
We can see it.
Cool. Very good. All right. So I have a Linux shell in Azure Cloud, as as Jay was mentioning. So, and I have a series of Terraform scripts that I've created previously. And literally all it takes to get started is you run Terraform plan, and that will, as Jay said, it's idempotent, so it will tell you what it's going to do. Oh. Well, that's I did not pray to the demo gods before this. I'm sorry. Here, let me see if it will just. Let me see if it'll just. Oh. All right. Oh. Yeah. So, but yeah, you would just run Terraform plan, and then you would run, and then it would give you a list of what it was going to do, and then
Hey, John.
Yeah.
So to give you an idea where you would be right here. So what it's asking for at this point is an RBAC service principal. And if you can easily, where it says the client ID and the secret, you can just, if you go and you generate a service principal ID, I can send you the information code really quickly. You can then just take those and paste those in really fast.
Oh no, I have them already. I mean, I have them. Yeah, no, I have them already. I just thought if I ran plan that it would just use the ones that I already had in the variable files.
Yeah. Then you would just have, because it's a new Cloud Shell, unfortunately, a Cloud Shell won't automatically init. So you'll have to go ahead and make sure that those environment variables are set.
Right.
Because you're probably using them as bash
Yeah.
Bash. Yeah. So it's
Yeah,
if they're bash, and there you go. That's all.
Yeah. Okay. Well, let me run to.
Sorry
Terraform.
to burst in. I just wanted to make
No,
sure
it's
that you
that's-
get your demo the way you expect it. There you go.
No, it's quite all right. I'm glad you were here to help. So yeah, so when you're cloning a brand new repository and you're going and you're doing everything brand new, you're gonna want to run Terraform init, and what that'll do is that will give you that'll give you everything that it expects to need as far as provider configuration, etc. And then you would run Terraform plan. Oh. And then you would run Terraform apply. Since I already have a plan file, I'm just going to tell it to use the one I already have because I generated it earlier. But it would give you a list, and then you would run Terraform apply, and then give it a. Okay, well. Like I said, I did not pray to the demo gods.
It's all right. Like I said, I think what you can do is grab your service principal key pair. Do you have it in one of your variables?
Yeah, I do.
So why don't you just cat it?
Yeah.
Cat and then copy paste, and it should go from there.
Oh, okay.
Yeah, at this point, what it's really going to want is you just fill in the variables to provide like the parameters to get you what you need. Yep, that's perfect.
Yeah. Oh yeah. And then.
Okay, so yeah, it looks like those are empty. Is
what?
Well, no, those would be in your parameters, I would imagine.
Right. So, but why? I thought I already gave this. I thought I already.
Yeah, it's looking for your client ID and your client secret.
Yeah.
So
I thought I already gave those default values. All right.
And so let me explain to everybody while John's doing this. So what it really is a service principal and the client secret is a key pair that you create within Azure Active Directory. And Azure Active Directory essentially creates a trust that you can have between Terraform and eventually your Azure account. So the point is you can do that also for an ACR and a Kubernetes cluster. And that's one of the big reasons why you need this here.
Yeah, and AKS needs to know what if you're building a cluster, it needs to know what subscription ID and so on that it expects to as far as what Azure account you have and so on. I have them saved in I have everything saved in my bash history, so I'm just gonna
yeah, let me go ahead and give you the command. It'll get you a service principal right now.
Oh, okay, thank you.
Let me put it in our chat if I can figure out where that is. Oh, I'm in full screen. That's why everything looks funny. Chat. Cool. So this is an AZ-CLI command. And so what I talked about earlier when I talked about Azure, our resource manager. Azure Resource Manager has a number of different ways to actually manipulate Azure. And so one of those is the REST API, where you can use whatever language you want, use the SDK, make the calls as you want. Then there is the option of using the portal, which is point, click, go, just like almost everybody else's cloud. And then the other thing that I really like using is Azure CLI, which is just AZ is a binary that you can download, or it's built right into the Cloud Shell, so that you can just use AZ commands built in. You're pre-authenticated. But if you want to run it locally, you can just type AZ login. It runs you through an auth process, and then you can go. You get it working, John?
Yeah, I'm running it right now. I'm waiting for the output.
So anyway, the other way you can do it, obviously, because Microsoft is using PowerShell, another one of the languages that are native to being able to manipulate things through the Azure Resource Manager. So PowerShell is a first-class citizen as far as being able to do any sort of manipulation of Azure.
Yep, that was great, Jay. I actually did get that to work, so thank you.
Hey, almost 2 years working there, and I kind of know what I'm doing.
Amazing, isn't it? Yeah, like I said, I did not pray to the demo gods, so I appreciate everyone's patience.
You know what? You do this long enough, you tend to want to help people just get through the moment.
Yeah.
At least when it's a collaborative digital situation, when you watch a person on stage kind of crumble. Nathan and I have definitely been in those situations where I've fallen to pieces.
Right.
But all you can do is just hope for the best. So I think we're all kind of lucky that in these situations digitally we can lean on one another.
Yeah, absolutely. And I definitely appreciate that.
It's why I literally do what I do, man. So while this is running, can you tell me a little bit about what just happened?
Yeah. So Terraform will go through it'll concatenate all your TF files in memory. And what it'll do is it'll go and it'll look for all of those resources that you have defined and make a list of every resource that you have in your resource list and tell you what it's going to create and what those different pieces of that are. So you see ID and you see all these kinds of other things that it will compute after you run apply. It will compute after it computes those values. It will insert them, and then everything about like auto scaling, default pools, all of those kinds of things. All of those will, and RBAC, it goes through and it goes through all of those different things.
So just kind of like how ARM works,
Yep.
It's going to declaratively build everything that you are requesting. And the only real difference between the two is just literally the types of the types of language. I mean, these is just Terraform plans are just JSON as well, right?
Well, these are actually what are known as HashiCorp Configuration Language, or HCL.
Mm-hmm.
So it's not quite JSON, but it's a similar kind of declarative syntax.
So like another kind of markdown derivative, if you will.
Mm-hmm.
So it makes a lot of sense. It's in the end, it's doing a lot of the things that I think, even I got to be honest with you, and I think it's scary to say it, but even CloudFormation at least has a syntax that's understandable. I think the one thing that I think both Terraform and also ARM have the leg up is that that XML is unwieldy.
Oh yeah.
Oof.
So and then after you run apply, it'll go and it'll build everything that you have specified. which is great. And it's something that I've always fallen in love with when it comes to DevOps Terraform.
So what kind of pipelines have you integrated this in with? Like, have you used any other particular kind of tooling to do the CI and CD around this? Because this is great for the infrastructure, but I'm curious, like, what happens when you want to test?
Oh yeah,
and all that other parts of it.
yeah. So we actually I've integrated it with both Azure DevOps and with Jenkins to do CI/CD for Terraform infrastructure, and I thought both of them were great. Because when I was working for clients, we could just clone repos and then make small tests and then and try them out and deploy them. It was great. Yeah, and the great thing about, I would assume, most CI/CD tools is most of them have Terraform support by now, which definitely explains why Terraform is so ubiquitous. And as I was saying earlier, in my experience, deploying AKS definitely seemed faster than some other things.
Speaking of fast in AKS, did you know AKS was like the fastest growing product that Azure has? Like, of all the products that they've ever built, none has seen a greater adoption than AKS, and I thought that was really, really cool. And I think that's just a tribute to the things that containers and Kubernetes team on the engineering side really have done. When you think about people like Lachlan Evans and Gabe Monroy, there's so many. Brendan Burns is part of that team. It's pretty incredible to think about, like, the work, and I can just say them because they're some of the leads around that team. Just the work that they've put in to get the product where it is right now is just pretty incredible.
It's definitely faster than EKS. EKS takes like 18 to 20 minutes.
Oh yeah.
So you would have to wait for your presentation to be over.
Yeah. And when I was testing earlier, I got it down to maybe 5.5 minutes, which I thought was a great improvement since, as you said, EKS takes between 15 and 20 minutes. Although Destroy took a bit longer than I thought, which I thought was kind of odd, but
One of the other
usually, yeah.
Oh, sorry, go ahead.
No, I was just saying you usually have other add-ons on top of just the cluster.
Oh yeah. Mm-hmm.
Yeah, Destroy,
Yeah, the destroy process, especially when you're talking about the other resources, like the way Azure will do it is the fact that you create the 3 VM node pool on by default. So it's going to create a separate resource group, a separate set of VMs for your node pool. And then on top of that, the virtual network and everything that's necessary to connect it all together.
Yeah.
The thing that I do like is that little bit of separation between the nodes and then the rest of the infrastructure, so you can just pay attention to the Kubernetes side. And then the multiple node pools thing is really cool.
Oh yeah, and being able to deploy that declaratively is awesome.
So one of the things that I could tell this group is, like, one of the things I've seen recently is confidential computing around those Intel chipsets. I think it's SGX chipsets.
Mm-hmm.
Those are going to be native to AKS at some point. You'll be able to deploy to SGX chips, and within the Kubernetes config files, work with that SGX security service to encrypt things that are going into memory by default through Kubernetes. So that's stuff I've heard people talking about. I know a company that does some blockchain stuff that's really been getting into it. So there's so many options around what's being built to make Kubernetes more than it already is for Azure.
Yeah, which is great. Now, in the space of 4 minutes, everything is done, and it'll tell you, five resources were added. It'll give you, the.
Can you close code?
Yeah.
Just so we can see a little more. Thanks.
Yeah, and then it'll give you, it'll give you a YAML file full of all of the stuff that it created, and that's really all it takes. It's kind of flabbergasting, how easy it is to deploy Kubernetes using Azure, and that's why we here at XOps have been so excited by how rich Microsoft's support for Terraform and Kubernetes has been, because it's a huge, like I said, force multiplier for our clients and for clients we support, because we can use that to leverage and help organizations leverage their infrastructure to help them deliver better software faster, which is pretty great.
I think we have like 5 minutes left, and I just was curious, does anybody have any questions? Because if not, I want John to show you one thing before we're all done.
Or the better question is, what questions do you have? Because nobody doesn't have questions.
What questions do you have for us?
I have a question. So in terms of, I use a lot of public Terraform modules. I don't work with Azure as much, but how's the support for, already built, publicly available Terraform modules to get going?
Yeah, I mean, I don't see why it would be any different. I mean, you would just include those modules in your, you would just reference those modules in your Terraform code, and they would be.
Yeah. And you just use a different provider.
Yeah. Oh yeah, you would.
Yeah, I think it's as simple as like specifying the provider, making sure that you have your parameters set for that particular provider, and then that's really it. I think that most of it will be pretty agnostic, except for anything that's like super cloud specific. And so in the case of like the differentiation between VPCs on AWS and then in Azure resource groups and virtual networks. So like you need to build around that, but for the most part, your plans and your templates that come from Terraform will do what you want. You just got to kind of work with it. Anyway, anybody else have a question or would like to tell us our question? If not, hey, John, would you do me a favor? Could you bring up in the portal the newly created Kubernetes cluster? Because I'd like everybody to see one really cool thing that you can do once you've actually built your cluster. So the first part of this.
Let me close the Cloud Shell, and then Kubernetes services.
And then if you go to the left side of the screen, what you're going to see something after you go to the cluster itself.
Mm-hmm.
On the left side of the screen, you're going to see something called the deployment center. And this blew my mind. Go into the deployment center, and you have created for you, with just a few clicks, your full CI/CD process into Kubernetes. Once you've actually created the Terraform plan, or you built it, whatever way you built your Kubernetes. So let's use GitHub. Let's say our code's in GitHub. So what it'll essentially do is ask you, please connect your GitHub account. Then once you do that, you authorize. So you say, yep, this is my GitHub account. Let me in. You click authorize. And so then after that, what you're going to do is provide the application. So you'll go within to the repo, you'll pick the specific code base or whatever the code you're going to deploy. The application will then look at the Docker file that you have.
Yep.
And so that Docker file eventually will build what you need, and then resources. So the resources will eventually create everything that you've had, put it within this new Kubernetes cluster, and eventually then deploy it using pipelines through Azure DevOps. So it will then create a release pipeline, and it'll create your Kubernetes manifests for your application, and it'll do all it through either Azure DevOps, or you can use your build provider and deployment as GitHub Actions. So it doesn't have to be Azure DevOps. It can be used GitHub Actions if that's what you're already using.
Yeah, that's awesome. I noticed this says it's a preview. How long has this been available?
It's been available for about a year.
Oh, awesome.
So I've used this to deploy. The deployment center is built into a bunch of container-based technologies in Azure. So Kubernetes, web app service, which is essentially just providing you containerized ways to run code. So simple APIs, whenever you want to do that, or even web apps. It's all easy.
That's awesome. Yeah, and it just goes to show my earlier point how it's kind of astonishing how easy Microsoft wants developers to be able to build on top of Kubernetes. Yeah, because I never saw this in AWS to my knowledge. That AWS made it this easy. So
a lot of other clouds are very, very focused on getting the infrastructure moved through. I feel like one of the things that and I'm not critiquing anything, I think it's just a matter of that it's very infrastructure focused with tools to build alongside, where I think that Azure is very, very focused on what the developer needs at every single stage.
And Jay, remember what you were saying about ARM templates?
Yes. So every single thing you build in Azure is exportable as an ARM template. So you won't even have to write it. You can build what it is you want in the portal, and then save it right in a library in Azure, so they don't even have to keep it. And if you want to keep it, you see that download, it's literally a zip file with all the declarative JSON in it. And then you can just, like I showed you earlier in the session, run it through the portal, run it through anything, doesn't matter. And if you run it through this, in this save section, you click a button called deploy, it'll just go ahead and allow you to run it right through the portal and start again.
That's awesome. Yeah, I thought since I saw that, I should show that off so that people can see what that looks like. Because as you were saying, it is pretty cool. So, I don't know. That's kind of all I had as far as a quick demo. I wasn't sure how extensive I should go with it, but I hope that was useful and informative and fun, and it really is easy as it looks, and I hope I hope it's something that developers and DevOps people will take advantage of, because it's pretty fantastic.
Very cool, John. Thank you.